Thank you, Paul, and thank you, Climate Change Institute and the University of Maine for having me. It's a great pleasure to be here, and it's going to be quite a challenge to live up to that introduction. It's a great honor to be here, and one that gives me no little trepidation as a historian to speak about climate history in the home of the acclaimed Climate Change Institute. Let me start by taking us all back right away to the balmy days of the late Roman Empire, to the 4th century of our era, to the early 370s. It is a bright and sunny day in northern Gaul, a day memorialized in a most elegant and refined poem by one of late Latin literature's greatest writers, Ausonius. We are in a time when Rome's armies and navies are once again victorious on the Rhine frontier, when the new capitals at Trier and Constantinople are overrun, not with barbarians, but with construction crews. A time when Aurelius Ambrosius, known to later generations as Bishop and Saint Ambrose, is still a high-ranking government official, when, as the Roman province of Africa reaches its incredible peak of wealth and comfort, the rhetorician Aurelius Augustinus, known to future generations as St. Augustine, opens a school for would-be lawyers in the megalopolis of Carthage and wonders about tempting his own luck across the sea on the fastest of fast tracks at the imperial court. Almost every sign in these years points to renewed centuries of Roman victory and success. It seems certain that the near-fatal crises of the 3rd century were but a bad memory. In these heady days of Roman victory and confidence, Ausonius, the most famous writer in Gaul and tutor of the young emperor in the northern capital of Trier, could not know that the good times would not last. He composed at this time one of the most beautiful poems about nature and Roman civilization penned by any Latin, Ausonius' famous Mosella, which describes the wayfarer's wonder as he rides from the mighty new fortifications along the Rhine, across the hilly plateau that separates the Rhine from the terraced vineyards of the Moselle Valley. The poet admires the vineyards, the water-powered sawmills whose screaming teeth carve the stone that will adorn the new villas rising around the imperial capital at Trier. He muses on the fishermen, and especially on their succulent fish. The proud Roman breathes freely, finally, in the bright sun that he says shines across the Roman space, civilized by the removal of dark trees and the dank, evil, stinking air of the forest. So fine and detailed is his account that we can track Ausonius' trip station by station, settlement by settlement, along a well-known road through the renewed prosperity of Roman Gaul. As Ausonius crosses the waterless ridge of the small settlement, today known as Kirchberg, he remarks, I quote, "I passed Dumnissum, drought-stricken, with its fields parched, coming and going." Now, over the last 300 years, historians and literary specialists have sifted through this little masterpiece with a fine-tooth comb, detecting every allusion, every nuance. A sheaf of slight indications, references to an imperial military success, allusions to an impending honor, and so forth, has given rise to a scholarly consensus that this poem was likely composed in or around the year 371. In February, I had the privilege of co-authoring a report published in the journal Science. Our colleagues in Europe had devised a new super database of more than 7,000 tree rings from northeastern France, from northeastern Germany, and from southeastern Germany. I'll tell you more in a moment about my very modest contribution to this enterprise. But the key thing to know is that because the annual growth pattern of oak trees in the forests we studied reflected in first and foremost the amount of rain the trees got in early summer, the new database allowed us to reconstruct from Roman and other archaeological wood the early summer precipitation in these areas for each and every year from about 400 BC to 2000 AD. So 3 weeks ago, as I was puzzling about how to present Ausonius's wonderful poem about the Moselle and the Roman environment to my little undergraduate seminar on the science and archaeology of the fall of the Roman Empire in Gaul, I read up on the debate about the dating of the poem. Of course, I had the full results of our study in my computer. And as I read the verse about the parched fields of Kirchberg, I got curious, even excited, and summoned up the Excel spreadsheet with our results year by year. Here it is. You can see that while not catastrophic, the spring rain, which fell on Dumnisum in 371, was not abundant. Out of the blue, a new natural scientific database published on February 4th of this year reconstructs ancient climate patterns and confirms in spectacular fashion centuries of classicist sleuthing. Early summer precipitation was on the decline in the 370s, and 371 marked a dry year after two rather wet ones. Ausonius was indeed describing the summer of 371 AD. This extraordinary convergence of ancient Roman poem and hyper-sophisticated new scientific data is what my friend Ed Wilson calls consilience, a fancy word coined in the 19th century that comes from two Latin words and means jumping together. Consilience happens when evidence of two completely different origins jumps together. Epistemologically distinct, the two different pieces of evidence come together because the reality from which each piece of evidence stems is one. The dendroclimatologist and the classicist findings converge and reinforce one another independently. You're the first audience outside of my 8 students in my seminar at Harvard University to learn about this particular case of consilience. This is but one vignette from an extraordinary voyage of discovery on the frontiers of the natural sciences and the humanities that are so central to the mission of our American universities and research institutes. A voyage of discovery that, for me, started in hilarious fashion with an extraordinary piece of great good luck, which Paul has mentioned to you, and which my wife and I were at first convinced was an extremely embarrassing case of mistaken identity. Out of the blue, 8 years ago, I learned that I'd won the Andrew W. Mellon Foundation Distinguished Achievement Award, of which I had never heard. It's a kind of low-key MacArthur Fellowship, except that the MacArthur is $100,000 a year for 5 years, $500,000. And the Mellon is merely $500,000 a year for 3 years, $1.5 million. Not being one to look gift horses in the mouth, I graciously accepted the award on behalf of the university. The dollars go into a university account, and I get to spend it on whatever scholarly and scientific endeavors I like, to the great disappointment of my then small children, who, when my wife and I explained Daddy's great good luck, immediately wanted to get in the car and go buy the local Toys R Us. So I used this incredible good fortune to set out on a new path, to explore how natural sciences might interact with humanities for the greater benefit of both. In particular, for the historical and archaeological investigation of the first millennium of our era in the Mediterranean world, broadly conceived. Tonight, I'd like to offer you a kind of progress report on the part of that adventure that concerns climate history. We are in the early stages of that collaboration of scientists, archaeologists, and historians, a collaboration in which the University of Maine's Paul Majewski has played a cardinal role. Our goal is to strive for the consilience of art and science, to use E.O. Williams' term, to bring together the natural sciences, history, and archaeology in multiple areas of exploration of the human past, to develop a kind of science of the human past. Our endeavor to produce a kind of white paper as the beginning point for further discussion and study of climate conditions under the Roman Empire, broadly defined as the period from about 100 BC to about 800 AD, this is one element of that broader investigation. We're in the final stages of writing up a study, or more probably two studies, which have grown out of a workshop of a dozen climate scientists, historians, and archaeologists, co-sponsored by my Mellon Award and by Dumbarton Oaks, Harvard University's great research center in Washington, D.C., which focuses on Byzantine, pre-Columbian, and landscape architecture studies. The results belong to the team of a dozen of us, and I will only be speaking on our team's behalf when I talk about them. We aim to turn these studies into a historical and a scientific article, two different articles for two different journals, and we've not quite finalized the whole picture. So I won't offer you any definitive conclusions about these climate conditions and how they interacted with complex patterns of political, cultural, economic, social, and general environmental change that affected the territories of the Roman Empire in these centuries. What I have this evening is more imperfect, but I hope more exciting, a work in progress. I can tell you about what ideas are out there about climate change in this era, including those just published results of a second research group in which I participate and which I've alluded to, and I'll offer you some details about our ongoing work. But first, a little background and some thoughts and examples of the extraordinary emerging convergence of science and history, what I like to call archaeoscience. This is about climate science, to be sure, but it's also about geochemistry, about genetics, about ancient DNA, and even about artificial intelligence. I'm a historian myself, lately immersed in archaeology. But what I seek to do is, by bringing together the science and the humanities, I'm looking to find a way of increasing the data available for us for resolving the great historical questions about the origins and rise of human societies in Europe in the first millennium of our era, and to offer the historical background and insights our scientific colleagues are increasingly requiring for the discoveries they're making. I'd like to begin by inviting you to think a bit with me about the challenges that face us when we address a historical question as big and as difficult as the fall of the Roman Empire in the context of the overall history of the first millennium of our era. Then I'll quickly go over some first results into the scientific investigation of different aspects of this period of the first millennium, both in my own work and that of others. But first, back to that really big historical question, because the fall of the Roman Empire is a really big historical question. It's an extremely complex historical phenomenon that fascinated and sometimes horrified observers for centuries. Anyone who addresses it faces four big challenges: its duration, its geographic extent, the question of the exact nature of fall, and the wealth and complexity of the evidence. First of all, duration. The Roman Empire lasted some centuries by most people's account, from Augustus in the 1st century BC to after Justinian in the 6th century AD. It was not some single event. The replacement of a puppet boy emperor in a navy base in northern Italy in 476 by a barbarian general named Odovaker, who also, it turns out, probably happens to have been the nephew of the empress in the real power center of Constantinople in 476. This replacement of a puppet emperor may have some symbolic value as the fall of the Roman Empire, but it certainly does not mark the end of the Roman Empire as the most powerful and influential military, political, cultural, and economic entity in Western Eurasia. That would not happen until 200 years later, when, in the 7th century, the all-conquering armies of Islam crushed the Roman army on the Golan Heights and stripped the empire of its richest provinces, the Roman East, which held as much as 2/3 of the entire empire's fiscal income and population. No, a far better reading of fall of the Roman Empire is as a succession of crises and recoveries that at the broadest scale lasted from the 3rd century of our era to the 7th century. The mighty edifice that was Rome did not succumb to any one cause, climate or otherwise. The geographic extent is the second challenge. This is a phenomenon which covered some 30 modern countries, from today's United Kingdom to Syria, from Belgium to Egypt. That spatial dimension implies a very rich diversity of ecologies coexisting simultaneously and in relatively intensive relations with one another. In climate terms, a non-exhaustive characterization would, according to a standard climate classification, assuming that the Roman climate conditions were basically analogous to the modern, and that is an assumption which obviously can be challenged, the territories of the Roman Empire embraced three of the main climate zones: arid or dry, warm temperate or humid middle latitude, and snow continental. So the geographic extent of the territory we're talking about is an extraordinary challenge. The logical nature of the fall itself is a deep problem. Was it a moral collapse? Professional historians have lately not devoted much time to the classical Roman historian Tacitus' idea of the moral decadence of the Romans. Tacitus, after all, was writing about 100 AD, 300 years before the real trouble started. It's as if Christopher Columbus wrote about the terrible decadence of the United States in the 19th century. And if fervent Christian belief and value systems are a measure of moral excellence, surely the Bible-thumping society of the Christian late Roman Empire must have been morally superior to their decadent pagan ancestors. How about politics? Fall can be charted in fairly straightforward fashion by the numbers of provinces directly controlled by the imperial government, whether that government was headquartered at Rome or at New Rome in Constantinople. How about then the barbarian invasions, or as they say in German, the people's migrations? There are differing opinions on them, as you can see from this slide. You can see how Americans during the Vietnam War imagined the Goths conquering Rome in the 1960s. Notice the strangely oriental appearance of the Germanic conquerors and exactly what conquering meant for civilization, and especially for young ladies. Compare that with how German school children were taught in 1942 to imagine the barbarian invasions, a peaceful, logistically, carefully planned movement of vigilant, serious men, women, and children, all of whom displayed perfect physical features of the blonde-eyed, blue-haired, dolicephalic master race. How about economies? Economic trend is more elusive, but some, like me, think that late Roman economic change probably deeply connected with political change. The evidence for economic change is growing by leaps and bounds, and that brings us back to the environment and to climate. The role of climate in the ancient economy is essential, starting with patterns of food production and moving on to its impact, for example, in the expanding or contracting hardiness zones of different life forms, such as mosquitoes. In our own time, remember, mild weather played an important role in allowing mosquitoes, which are bearers of West Nile disease, to survive their first winter around JFK Airport, where they had come in airliners from Egypt, and spread now far across our continent to points where there are no freezing deep winters to destroy them. Under the Romans, climate may have influenced the expansion of mosquito-borne malaria in the late Roman Mediterranean, possibly correlated with the distribution of the genetic anemia beta thalassemia, kind of a Mediterranean equivalent of sickle cell anemia. Climate may also have played a role in fostering the establishment of one of my favorite beasts, the black rat, a subtropical animal which arrived from India and then colonized Western Europe on the back of the Roman infrastructure, with even more drastic implications for the disease configuration of the late Roman world, since if the Justinianic plague, which hit the Roman Empire in 542 and lasted 200 years, was indeed Yersinia pestis, the bubonic plague, and I'm putting together, I hope, in coming weeks, a new research project to investigate that from the ancient DNA. If it was the bubonic plague, then this terrible Justinianic plague was first and foremost a rodent disease which relied on Rattus rattus and its fleas as its principal vectors to attack humans. Rattus rattus is a subtropical beast. Climate is therefore of great interest to its spread. The fourth source of challenges to those who would study the fall of the Roman Empire is the very wealth and complexity of the historical and archaeological record. From the point of view of the written sources, the literary sources are extremely rich, but extremely uneven, and they fuel discussion since an early date. Over the last century and a half, they've been joined by an ever-growing mass of documentary sources, principally the papyri, principally but not exclusively from Egypt, which are business records of private and public activities written on papyrus, which is the paper of the ancient world, and preserved in the garbage dumps of Egypt, and the inscriptions, which come from all over the Roman Empire, which are public documents of political and personal statements, fiscal provisions, for example, customs duties on various wares at a city gate in order to prevent bakshish, bribes, or purely utilitarian, like the milestones that stud the Roman highways. Then there's the Archaeological Archive, which has been exploited for over a century, but with the advent of newly precise ceramic typologies, which allow us to date individual pieces of pottery and therefore the archaeological stratum in which they are found, and with the gradual extension of radiocarbon dating to classical sites, which is only occurring today, and the ever more refined prospection and excavation strategies that it's developing, archaeology is yielding every day an astonishing mass of totally new data from the material world, the material culture of an ancient civilization in crisis. From the tons of ceramic that one finds in ships and in the soil, which range from the Tupperware to the Coke bottles of antiquity, to entire ships and their cargoes. Finally, there's the newest evidence, the Natural Scientific Archive, the completely new data emerging from the soil and the sea, ranging from the biomolecular testimony of ancient human and animal remains to the events that are buried today in our living modern genomes. For our climate purposes, as you may know, we use indicators of different sorts. For example, the Greenland ice cores, and first and foremost, the GISP-2, developed and directed by Paul Majewski. Dendrodata, tree rings, glacier movements, varves, and pollen corings, the changing spectrum of biota, of living creatures in a particular place. Proxy indicators derive from these data. They are indicators, they are types of local evidence, tree rings, ice core, lake sediment deposits, alias varves, which can be interpreted on the basis of established physical principles to represent some combination of climatic-related variations back in time before we have access to the instrumental records that essentially testify only to the last 100 years. Obviously, before a phenomenon or phenomena of the scale and complexity of collapse of the most complex and advanced economy Western civilization and maybe the world would see until, say, the 16th or 17th century, obviously seeking only one sole cause for such an extraordinary development or series of developments would be a waste of time. We must rather be alive to the interaction of multiple series of causes and interactions ranging from changing attitudes towards society to varying climate conditions. As a general proposition, I've been working to find and to begin to exploit new evidence about the first millennium of our era. I've actually learned in my old age to handle a trowel and have plunged into archaeology in the company of some accomplished specialists, as you can see from this photo of our charcoal collecting procedure for radiocarbon dating in our late Roman excavation in France. Lately, we've been having great fun at Harvard, and others are having great fun elsewhere, although unfortunately, mostly not in the United States, attacking important questions of the first millennium AD from the vantage point of the natural sciences, trying to extract and sequence the ancient DNA of the pathogens most often evoked as the cause of the Justinianic plague that marked the last century of the ancient world, and of the Black Death that affected Western Eurasia, or Eurasia entirely, from the 14th century to the 18th, as well as the present third pandemic of plague, trying to extract and sequence the ancient DNA of the pathogen itself from the remains of victims from plague pits from the period. Or using mass spectroscopy, here we are trying to extract some ancient DNA, or using mass spectrometry to identify the changing isotopic dietary signature in the bones of working class people in Italy between 600 and 1470 AD. We did a study on the Mediterranean diet and how it changed between the late Roman Empire and the Renaissance. And we were able to show, to our surprise, that fish consumption soared in the 15th century. And the only way to explain that soaring of fish consumption among working class people in the 15th century was the linking of the Atlantic and Mediterranean economies in Renaissance Rome with the import of cheap North Atlantic pickled herring by sea into the Mediterranean. Here, the isotopic data of what these men, women, and children had eaten was preserved in their bones and confirmed and extended the evidence of the archives of the Italian businessmen of the Renaissance who took in hand the importing of pickled fish. With my students, I've experimented with a new digital science of geographic information systems. We've now launched the prototype of a series of GIS, Geographic Information System, GIS databases called the Digital Atlas of Ancient and Medieval Civilization, which we put up on the web for everyone to use. You can check it out, use it for free. Finally, I've become heavily involved in the environmental archaeology of Western Europe at the time of the fall of the Roman Empire, centered around a late Roman small town that I am co-excavating with a German colleague. That place is called Tarkampol. It is the exploration by means of environmental archaeology of a barely known late Roman small town, Adekempagos, at the 10 counties, modern Tarkampol, on the Roman road between Strasbourg and Metz. While the archaeology focuses on the environmental and economic history of this small town, we're seeking to set it in a broader regional and interregional context. Our non-destructive survey of what lies underground uses geomagnetic prospection. The detection of underground geomagnetic anomalies allows us to discover buried structures, as you can see from the slide. And the first 5 trial trenches indicate that late phases of this town are relatively well preserved and that they are, in fact, 2 centuries later than commonly believed, than we believed when we started out. The concordant evidence of excavation, ceramic sherds, coins, and radiocarbon now prove that, contrary to all expectations, Tarkampol had come back to life, indeed was founded anew, probably by the imperial Roman government, and flourished between about 350 and 450 AD. So these are some of the new approaches that I have been applying with my colleagues at Harvard University and other research institutions in North America and Europe, including the Climate Change Institute here at the University of Maine. One extremely important methodological point has emerged from the very exciting work of our own and other excellent teams active in this new frontier of human discovery, the scientific exploration of the human past, or what I'm tempted to call the new super interdisciplinary field of archaeoscience. It is absolutely necessary to develop multiple but independent avenues of exploring the questions that we're interested in. Climate change is another important part of that picture. For instance, as you've heard, I had the great good fun of collaborating with that European team of dendroecologists and paleoclimatists on the precipitation history of Central Europe from 400 BC on, in which I used the wealth of published medieval eyewitnesses available in Harvard's Widener Library to verify the record of precipitation established from the analysis of growth patterns of 7,000 trees by our European colleagues. Remember, climate scientists deduce ancient climate patterns by comparing modern natural climate records or proxy data, such as tree rings and ice cores, with the instrumental records of temperature, precipitation, etc., that exist for the last century or so. Then they use the signals from the earlier proxy data to project those same climate conditions into the past. However, The impact on the environment of human-induced change, such as the Industrial Revolution, is so great that some have doubted whether the climate mechanisms observed over the last century or so applied in the more remote past. So I proposed in this case to test the team's new data on droughts and heavy rains against the historical records from the Middle Ages. From 1013 to 1504 AD, I was able to identify 104 eyewitness accounts bearing on 32 of the extreme precipitation years deduced from the tree rings and composed in the areas where the trees were growing. For 30 of those 32 years, the medieval eyewitnesses reported the same precipitation extreme as the scientists had already deduced from the tree rings. The human confirmation strongly argues that the same climate mechanisms observed today applied in Europe in the Middle Ages, long before the Industrial Revolution began to transform the natural environment around 1800. The extraordinarily rich record of Europe's deep historical and archaeological past is proving indispensable to scientific efforts to understand today's global present, even as the new scientific insights are shedding unexpected light on the human past, as our opening encounter with Ausonius' poem Mosella suggests. That light extends to the greatest of historical enigmas, the fall of the Roman Empire. Thanks to the extraordinary conditions of the Mellon Award, I was able to organize a first workshop on climate change in the first millennium 6 or 7 years ago. It brought together climatologists as well as paleobotanists, dendrochronologists, historians, and archaeologists. And thanks to the work of Paul Majewski, it proved to be a success. One of the major conclusions that emerged from that meeting was that we historians and archaeologists were amazed at some of the high-resolution scientific data available for climate history. And climate scientists were no less surprised to discover that, contrary to what they'd been led to believe, the first millennium of our era was not some complete dark age in which nothing had survived and from which nothing was known. We wanted to get new data for our research into social and economic history. You wanted to see the new data on the human impact of the changes that they had already spotted in the various proxy indicators, especially since to some, the medieval climate optimum, which ran roughly from 800 to 1200 AD, looks like an approximate analog of recent decades. The direct result of that meeting was that I teamed up with my friends Paul Dutton, the Carolingian cultural historian, and of course the man who needs no introduction here, Paul Majewski, and used Paul's work on the Greenland Ice Sheet Project too, one of the first high-latitude ice cores of such great importance that went down over 3 kilometers and produced a paleo-environmental record of the last 110,000 years, and because of the care with which Paul and his team did the work, had a very, very high-resolution record, also for the more recent times, modern times, the first millennium AD. To make a long story short, we compared the record of extreme volcanic eruptions somewhere on the globe as recorded in GISP-2 ice core sulfate deposits with extreme winters recorded in Western Eurasia at the time of Charlemagne's revival of the Roman Empire around 800 AD. Extreme volcanism, as you may know, is known to cause rapid cooling by blocking solar radiation. We were able to correlate the ice core's volcanic eruptions with extreme winters in Europe and Western Asia, mentioned in Latin and Greek records, and for the first time explain the seemingly random series of famines and catastrophes that befell Europe at that time. So what do we know today about climate conditions at the time of the real Roman Empire, broadly understood from about 100 BC to about 800 AD? This was the focus of a second workshop held 2 years ago at Dumbarton Oaks. We expanded our chronological focus so broadly so that we could see stability and change more clearly. Trends clearly emerge more distinctly over the long haul. Of course, no one can do something like this by themselves. The first task was to assemble a group of scholars, archaeologists and historians and scientists, dendrochronologists, glaciochemists, geochemists, atmospheric specialists, paleobotanists, and specialists in climate dynamics who bring together different data sets and different expertises to this extremely complicated problem. And so we met for 2 days of work in 2009 at Dumbarton Oaks, using different kinds of evidence. We used the paleobotanical data from varves, which are undisturbed, yearly layered deposits, even seasonally distinguished deposits, from lake bottoms in the extinct volcanoes of Germany and the lakes of Western Asia. We used new tree ring data from the Moselle River Valley around the late Roman imperial capital of Trier, and equally new tree ring data from the just discovered 6th century dock structures of the great late Roman harbor of Constantinople, modern Istanbul. We used ice core data from the U.S. Greenland Ice Sheet Project. We also used some of the European data from the GRIP project, which for the 5th and 6th century appears to be more detailed than the U.S. data. We used the most recent data on glacier advances, signaling cold periods, and glacier retreats, signaling warm periods, in the Austrian and Swiss Alps. Almost last, but by no means least, we assembled the written data. Two historians, Kyle Harper of the University of Oklahoma and myself, analyzed the written sources and built a database of climate anomalies recorded in the written evidence. We have at present about 700 references for the period between 100 BC and 800 AD. But many of the events will turn out to be of lesser significance on the hemispheric scale, or less well documented than we would like. I would guess that we will wind up with about 300 data points from the written records, but that will still be a significant advance over 0 data points. And it will provide what one climate scientist has called the ultimate in climate proxy data, a human eyewitness to the real impact of climate events that are otherwise only deduced from chemical or physical signals. Finally, specialists in climate dynamics are trying to analyze the patterns that appeared in the hidden correlations between ocean and atmospheric chemistry. For example, the oscillation of high and low pressure centers over the North Atlantic, or the ENSO, the El Niño southern oscillation, which even from the Pacific can affect the tracks followed by moisture-bearing storms that crossed the Roman Empire. Climate dynamicists may be able to shed some light into how geographically differentiated patterns might fit together. What did we find? I can't tell you everything because we're still drafting the articles, but I do have a few hints that I can share with you tonight. A first very important conclusion is that our various proxy data confirmed and made more precise earlier hints about climate under the early Roman Empire. The early Roman Empire enjoyed very, very favorable climatic circumstances, at least in northwest Europe. Long, warm summers favored food production, the indispensable foundation of any economy. Among archaeological testimony to the climate are the flourishing vineyards of Roman Britain and the nettle bugs, Heterogaster urticae, at Roman York in northern England, a beetle that likes warm climate and was absent as far north as York until the 1980s. Greenland ice core data, retreating Austrian and Swiss glaciers, Austrian dendro data on temperatures all agree on this score, as does the fact that the Alpine glaciers were smaller in the 1st and 2nd century AD than they were around 2000 AD. One important climate forcing factor also shows unusual stability. Volcanic activity, which shoots sulfuric acid up into the stratosphere and blocks solar radiation, causing sudden cooling. Volcanic activity is not evenly distributed over time. An exceptionally low level of volcanic activity prevailed from 44 BC to 152 AD. You can see this spike, which when it was presented in our first climate meeting with Paul Majewski at Harvard some years ago, all the archaeologists and historians went, Vesuvius, recorded in the ice core of Greenland. The GISP-2 record shows that in the early Roman Empire, Vesuvius was the only major recorded event in the snow of Greenland. For the first 150 years of its existence, the Roman Empire was almost completely spared the potential effects of volcanically induced rapid climate change. In a sense, a warmer, more Mediterranean-type climate prevailed north of the Alps around the time of Jesus, allowing the Romans to colonize Europe and to import elements of the Mediterranean ecology into northern Europe. But As we noted at the outset, the Roman Empire covered multiple climate zones. There are some important indications of differently positive conditions in the other regions of the empire. From an archaeological perspective, my late friend, who also participated in that first workshop with us, the Israeli archaeologist Yitzhar Hirschfeld, made a very interesting argument based on the history of buildings along the changing coastline of the Dead Sea. Dead Sea levels reflect precipitation and water usage for a large area of the Levant. Yitzhar observed that early Roman buildings seem to have been underwater in late Roman times, when the Dead Sea shore reached outward. He estimated that the Dead Sea was up to 10 meters higher in the late Roman Empire, which would confirm some paleoclimate evidence that the 4th to 6th centuries were exceptionally humid in the Levant. Other natural scientific evidence from the Roman siege works at Masada might indicate that the 1st century AD was also somewhat cooler and wetter. If a considerably wetter late Roman climate in the Levant were confirmed, this would help to explain the extraordinary shift of the center of gravity of the late Roman Empire from the Western Mediterranean, from Italy, Gaul, and Spain, toward the Eastern Mediterranean of Constantinople, of Antioch, and Alexandria. In fact, the Washington workshop seems to confirm the wetter trend in the Middle East from the 1st century BC to the end of the 2nd century, and again in the 4th and 5th century, just at the peak of power of the eastern part of the Roman Empire. This comes from evidence in the written sources, from the further study of lake levels, and some early evidence about precipitation from cave deposits called speleothems. The 3rd century AD is known to Roman historians and archaeologists as a time of political, military, and economic crisis, especially in the empire's northwestern provinces. The climate record then is of particular interest. The 3rd century shows sharp climate change. The proxy data indicates a marked shift away from the stability of the 1st centuries and a broadly cooling climate as a background factor in the northwest province's turbulent 3rd century. Volcanic events peak then, in contrast to a much calmer 4th century. Between 3 and 5 volcanic eruptions concentrated between about 235 and 285 and potentially triggered commensurate episodes of rapid climate change. The Greenland ice core shows slow increase of sea ice, that means cooling, in the 3rd century. The long retreat of one of the largest and slowest reacting alpine glaciers comes to an end, and it begins to grow again in the 3rd century. Very dramatic change occurs in the summer precipitation in northeastern Gaul, as you can see from this figure. April, May, June rain declined steeply from 235 to about 310 AD. Such rapid short-term changes would have had a tremendous capacity to disrupt food production in the most difficult decades the Roman Empire had faced so far, for the political and military and monetary crisis peaked between about 250 and 290 AD. In the eastern provinces of the Roman Empire, the Talmud mentions droughts in Palestine between about 220 and 240 AD, and multiple historical records document a general drought that lasted from 311 to 313. The Dead Sea levels unambiguously indicate a sharp drop in precipitation, followed by a steep rise in precipitation that may have lasted 200 years. The return to humid conditions in the east occurred between 300 and 400 AD by the imprecise dating of radiocarbon. On balance, the proxy data points to a fairly stable, cooler 4th century that warmed in the second half, at least in the northwestern province of the empire, a time when, as we've seen, Roman power recovered there. As we've already seen, hints of wetter, more favorable conditions in the eastern provinces of the empire in the 4th and 5th century, precisely the Eastern Empire's historical peak, when the capital of the Roman Empire was transferred to Constantinople, modern Istanbul, and the eastern provinces surged ahead economically, culturally. This was the time of explosive growth of the Christian civilization of late antiquity in the eastern Mediterranean. The 5th century looks less favorable for the Western Roman Empire. Greenland sea ice indicates 5th century cooling that peaks around 540 AD. Even with a gap in the GISP-2 record, the 5th century was almost as active volcanically as the 3rd, so there was considerable potential for the disruption of volcanic winters, regardless of the overall temperature trend. In northeastern France, summer precipitation again shifted from very wet around 450 to very dry conditions. Dry conditions which would prevail for the next 2 centuries. All in all, initial indications are that the 5th century was a time of unstable climate conditions in the Western Empire, even as more favorable climate conditions prevailed in the eastern provinces. The 6th century brings us to one of the most dramatic episodes of rapid climate change in the history of Western civilization. The big story here is the 536 event. We're finally making real progress on the 536 event. It's described by at least 3 contemporary eyewitnesses as a terrible and terrifying dimming of the sun that lasted between 12 and 18 months. Procopius and his contemporaries are referring to an abrupt reduction of solar radiation which lasted many months. This event was pretty much ignored by professional historians and archaeologists, like Mike McCormick, until 1999, when 2 popular works by amateur historians propelled it to the center of much heated debate. The exquisite understatement of their titles says it all. David Key's Catastrophe and Mike Bailey, From Moses' Exodus to King Arthur, Catastrophic Encounters with Comets. They used well-known dendrochronologist Bailey's excellent Irish tree ring data to show the reality and severity of extraordinarily dramatic stress on Irish oaks in 536 and argued that a climate-forcing event of global scale occurred then, which they claim is the greatest natural catastrophe in recorded history. One that they thought was caused by either a gigantic volcanic eruption or asteroid impact. Whichever the cause, it wrecked, according to them, established civilizations and ushered in new ones, causing invasions and the outbreak of the Great Justinianic Pandemic of Plague in 541. In some, the comet, asteroid, or volcano itself caused the fall of the Roman Empire and the end of civilization as we know it. Of course, the fact that the Roman Empire was actually fairly successful over the next 100 years after the 536 event might tend to relativize somewhat the long-term impact of this indubitably powerful case of climate forcing, even allowing that the late Roman success came despite a series of problems that make our recent economic woes seem almost like child's play. Although the level of historical analysis of these books could charitably be described as mediocre, the authors deserve full credit, and they've earned my personal admiration for attempting to match the written record of late Roman civilization with striking natural scientific data, which does indicate a major short-term climate event in 536. Their work has spurred a series of learned critiques, rebuttals, and reappraisals. Most importantly, Larson et al. In 2008 demonstrated the dramatic geographic scope of a stress signal in tree rings across Europe and correlated it with another Greenland ice core with a strong sulfate signal, which they dated to 533, 534, plus or minus 2 years. If that ice core is correctly dated, then the volcanic nature of one of the most massive climate forcing events in the last 2,000 years is established. To this, I can add a piece of new evidence that comes from the research of 2 of my colleagues in Harvard's climate research program, Peter Hybers and Martin Tingley. Dr. Tingley kindly analyzed the proxy record they are developing for their own paleoclimate studies, which are independent of those used by Larson et al. And as you can see, here too, the strong cooling effect of around 536 is unmistakable. The way is clear for further and more sober appraisal of the environmental and economic consequences, particularly the potentially geographically differentiated consequences of that terrible year. And it is clear that it was a terrible year. Yet even so, it added to the burdens borne by the Roman Empire and did not bring it down. Even in climate history, there's no room for monocausality. There are finally some serious signals of droughts in Central Asia in the 4th century, a period which coincides with important migrations of nomadic pastoral raiders to the borders of the Roman Empire. And our group is right now probing possible links between the North Atlantic Oscillation and political instability in the West Roman Empire. Stay tuned for more on that. There are therefore already some hints of rapid shifts toward favorable or unfavorable climate conditions, at least in the western parts of the Roman Empire in periods of crisis. Now, I'm not about to claim that climate anomalies, whether caused by volcanoes or by any other climate forcer, determined the course of empires and civilizations. Nevertheless, climate change certainly was capable of playing a role in the complex unfolding of human history. The occurrence of a climate anomaly, such as the tremendous volcanic winter of 536, did have serious economic and human consequences, including mental ones, even if it only weakened and did not destroy the late Roman Empire of Justinian. Let's reflect for one last moment on one new fact about the 536 event. The study of 2008 presents sulfate deposits in Antarctica which have been correlated with the 536 eruption. This, the authors maintain, implies that the volcano responsible for the dust veil event that so deeply affected the northern hemisphere lay in the tropics, whether in America, Asia, Oceania, or Africa. In our narcissistic way, we're inclined to think that we are the first to live in an age of global history. But in the 536 event, we have a natural phenomenon which likely occurred thousands of miles from Justinian's resurgent empire. Whether the volcano was in America, Africa, or Asia, and regardless of whether Roman soldiers, peasants, senators, and priests, or their barbarian adversaries were aware of it, this distant natural event impacted their lives quite severely by bringing major military operations to a standstill and causing food shortages around the empire. They, too, lived enmeshed in a global environment and suffered the consequences. This eruption, this event, invites us to think more deeply about the interweaving of human and natural history as we stand on the threshold of a new period of historical investigation when totally new and unexpected data is beginning to reveal intelligible patterns of cause and effect in what had hitherto been viewed as unintelligible or at least as patternless. Some years ago, my distinguished friend and colleague, Bernard Bud, to his friends, Balin, anticipated the growing integration of what he calls latent and manifest history. Latent events are deep developments whose effects contemporaries felt, but of which they were unconscious, demographic or slow climate change. Manifest events, like extreme winters and famines, are those that contemporaries perceived. The new data from the science of the human past can recover that latent history and begins to suggest how it might be integrated into our established narrative of manifest history. Although the exact timing of volcanic eruptions somewhere on the globe is, so far as we know, unpredictable, the mechanism and nature of the impact of those distant events on the peasants working in the fields of late Roman Britain, Gaul, Italy, or Africa are not. Volcanic winters cause crop failures. They cause death and destruction, weakening the general health and economy of a civilization whose defenses might already be diminished. The volcanoes whose eruptions are recorded in the Greenland ice sheets erupted as far away as Japan and America. Far from the intentions and mental horizons of late Romans, the global climate system prepared rude blows for men, women, and children across at least parts of the Roman Empire. 10 years ago, detecting this would have been impossible. In the future, historians and archaeologists will gain further new insights from the advances of the natural sciences. The one thing we can truly expect from the investigations now underway is that they will make clear in a very unexpected way that here, too, the historical experience of the Roman Empire and of the civilizations that arose from it were anchored in global realities, including the spectrum of environmental change studied with such distinction at the Climate Change Institute. Combining the discoveries of 21st century science with the extraordinarily deep and varied historical and archaeological record of ancient and medieval Europe promises a rich harvest of new insights for specialists of the global present, no less than of the human past. Thank you very much.